Okay, we continue our class. So today we learn a new term called instantaneous center of zero velocity. So it's a position where we refer to 90 degree to our velocity. Okay, it's a position on the body. Let's say on the diagram that you see on the screen here. So you have a body that rotates in a certain way. We refer to A, and then the A is rotating. So the velocity is tangent to the curve, to the path, blue line curve here. So we can identify the location of instantaneous velocity, zero velocity, by having 90 degree to your velocity. Meaning you use your ruler and put the base of your ruler to the velocity, and then you just follow the body of your ruler, and then you draw a straight line. Then you intersect something that is called centroid, and at that intersection point, I see here, the velocity at that point is 0. Meaning it's an observing station. You know where the observer is. Okay. So there are several possibilities exist when you want to find the location of IC. So first, you need to identify your velocity first. IC always relate to your velocity. So velocity of the body, let's say velocity VA, and the angular velocity omega are known. So you must know your velocity and also angular velocity omega. These two things you must know on the body. So the way it rotates, and we are using right hand rules. We're using right hand rules. So in this case, like what you see on the screen here is pointing inside the screen. So the direction is inside the screen. So if you convert into vector form, your k, wk will be negative, negative wk if you convert into vector form. Okay. So once you know your v and omega, then you can measure the distance from A to the IC, which is the RA stroke IC, the position where the fixed point of instantaneous velocity. You label as R, A stroke AC means from IC, is given by this formula, velocity divided by omega, or the formula that we memorized yesterday, V equal to omega R. Okay, so for rigid body, the conversion between velocity and omega is V equal to omega R. Okay, and this is just a notation for where is the position. Means we're still using the ruler, the base referring to the V, and the body of your ruler is referring to the direction of your IC. Okay, so this diagram, when we have on the body, on the same body, when you have 2 points, point A, point B, and the body is rotate in a certain omega. So to find IC instantaneous center or IC of zero velocity, you must know two parameters, V and omega. Once you have this one, then use your ruler again. You find where is your V, your vector V, and V must always perpendicular or tangent to your circular motion. You refer to point A. So the blue curve, and you draw the tangent velocity. Once you draw the tangent velocity, you use your ruler. The base of your ruler, you align with VA, and then you follow the body of your ruler. You draw a line that give you the line of RA stroke IC. And then you go to B, do the same. You know the rotation omega, and omega is clockwise, so you know that the V is pointing down and is perpendicular to the curve. So perpendicular to the curve, then again use your ruler. The base will be aligned with the VB. The body of your ruler will you draw, and then there's an intersection between A and B. between the RA stroke IC and the RB stroke IC. Then you will come to a point called IC. At IC, the velocity is 0. Okay. Yeah. So this one, when there's an intersection point, then you can draw lah. So you need to know the exact location of VIC. You need to at least need 2 points on the body. Okay. Okay. Now we extend what we learned a few minutes ago. We focus on the left-hand side diagram. Let's say this body rotate and clockwise. Rotate clockwise, if you use your right hand rules, is again negative WK going inside the screen. So this body rotate clockwise. And where is the location of IC? You need to pinpoint 2 points. To get IC, you need to have 2 parameters, omega and V. So you go to point A, and then you follow the omega, which is clockwise. So you know that it's in the curvature motion, the curve here at the point A here. And then you draw a 90-degree or tangent direction, velocity. And you move your ruler, the base aligned with the VA. And then you draw a line with the body of your ruler. You draw down. And then you go to B, you do the same. B will move, VB will move to the left because it's rotate clockwise. Okay, and then you use a ruler again, align your base of your ruler with BB, pointing to the left, and then you draw a line with the ruler body, and you have one intersection point which is aligned with point A also. Okay, and the vector IC to A or IC to B always pointing out from IC. Yeah? So you're always pointing from IC to the point, IC to the point. Okay, so this is how you draw a diagram. And you have a distance between A and B. And we define as D here on the diagram. Okay. So this comes with one conclusion. When your velocity of A and B, they are parallel, the vector of A moves to the right, B moves to the left, but they are in the horizontal. So if you have two vector velocity that go parallel, your IC will be at the center of the two lines. Or not center, but it's in the along the line between point A and point B. Okay. But yeah, okay. And to find the exact location, you just add one more line with the arrowhead of your vector and join to the arrowhead of A and B. Then you get the exact point of your IC. You just go to your, when you draw vector, you just draw like, let's say this is 1 kilonewton. So this one is 1 cm. This one is 2 kilonewton. Then you draw 2 cm. Then you join the arrowhead. Okay. So still the same. We are seeing V equal to omega R. V equal to omega R. So this is how you find the distance instantaneous center of zero velocity IC. You use this formula to calculate the magnitude of the line. RA stroke IC equal to V divided by omega. And if it's from point A, then you use velocity A. If it's B, then you use velocity B. Yeah? So it's the same. Huh? Okay. So if D is given, you only need to find one point. Then you can find another RBC. Yeah, this is the formula. It's the sum of the two distance, A to IC and IC to IB. This is just a diagram formula. D equal to two distance. Okay. Okay, so we move to the right hand side diagram. Same, one body rotate anti-clockwise. So anti-clockwise, the W is pointing outside the screen, is positive omega. So you pick 2 points. You pick 2 points in the body, and because it's anti-clockwise, you know that B will move a curve, A will also move a curve. So what you do, you repeat the same procedure. You draw the vector of velocity first, the VA and VB. Then you use your ruler, put on top of the vector, and then you draw straight line. Here, you also meet another point of IC, and then you get the distance of D. Okay. So it depends how you draw and where's the location. If the two vector velocity, they are going opposite direction, like the one on the left diagram, VA go to the right, VB go to the left, they are parallel but different position or different direction, then you use addition plus. D equal to RA stroke IC plus RB stroke IC. However, if 2 points, the two velocity vector going parallel, you use this D equal to RB minus RA. Yeah. Okay, application of IC also the same. Is another way of solving planar kinematics of body. So you have two scenarios there. One is piston. So you have to identify what are the motion that you have. So let's go to the piston first. Piston head C. C is only having linear translation. Okay. B, B later. Okay. A to B. What is the motion? Rotation. Okay. B is general plane. B rotate and also translation. B is general plane. So same. So below diagram also, you should able to identify what are the motion that you have. Like for example, DC is having rotation, AB also rotation, but C is having up or down, right? Yeah. Okay, so this is just elaboration of what you have. So point B, it asks you to determine the location of instantaneous center of zero velocity or IC for member BC. Okay, for member BC, it's just you need to know two things when you draw IC: velocity vector and also omega. Okay, look at point BC. You draw point BC, and then you go to the point B and you draw the path first, the path for point B, and then you go to C, draw the path for C. You should be able to draw. B, where is the vector? Velocity vector. Go down, because it's rotate down. It rotate down, rotate down. So velocity go here. Point C, velocity is going to the x direction, to the right. So you label BC and then you start to draw for point B first. Point B, once you have the vector, it can be direct down or it can be a certain direction. Okay. So this one, as long as tangent. So you draw a tangent vector VB, and then you use the base of your ruler, align with the arrow tail to the arrowhead, and then you draw a line with the body of your ruler from the point, from the point, not from the arrow, but from the tail of the arrow. So you draw this line. Okay, so there's an angle there. So later we come back with the angle. So VC will go straight like this, horizontal. So you have two vector, and you know that this one is rotate this way. Is a combination of two translation or two motion, general plane. Okay, are you able to draw the IC? You should able to draw. This one, you use your ruler, align with this one, and then you draw a line. You draw a line to here or to here. You can draw two directions, here or here. Your objective or your endpoint is to find intersection point. So here, you align the base of your ruler here, and then you draw up or down. So you will see intersection point in one side of the body. Okay, like this. So it's important you draw your vector velocity b. Then you'll give you, they will sure have one intersection point. Okay. So the dot line is what we want to see in your test. Okay. Yung dot line to represent the line for the RB stroke IC or RC stroke IC. Okay, so this one, Y direction is this one because we're following the B. The B is given in the question already. Given a question like this, and then it must rotate like this. This arm must rotate like this. Okay, so the body WVC of angular velocity, you must imagine the motion, because this one push down and then this one push to the right. So it must be rotating anti-clockwise. Okay, the body like this. You can use your pen or pencil to imagine the link of VC. Okay. So this is a complete diagram for identify the IC. So this one will expect in your test too. Quite direct and quite easy to find IC. As long as you know and you come to class, then you know how to draw. And then you must label. You must label, don't just leave in a dotted line. You must label where is your position RC stroke IC and RB stroke IC, and always pointing from IC to the point. The arrow always pointing from the IC point to the B, or to the interest point. In this case, IC point to B, IC point to C. And then must give the arrowhead, must write a arrowhead there, direction. Okay. All right. Now, from here, you can able to identify and calculate parameter. You can able to calculate VC, RC, and omega. One of it will be missing. So in this case, omega usually will be given. So once you omega you know your velocity, you can find the R, because V equal to omega R. Okay, all this question is just test you one equation only. V equal to omega R. But must write correctly the sub one omega BC, RC stroke IC, and so on. Okay. Okay, this one repeat the same. If you want to find the link of C to B, where is the location? If you draw, C will pointing down, right? C will point down, right? C will point down. Oh. C, if now the question change, we focus on CB. So CB, it rotate in this way. So this one will go down. So C velocity will follow the curve. So this is your VC. B will also go down, VB. So both will not, if you draw the line, IC line, you're pointing this way. This is your IC line. So there's no intersection point. we will give infinity, so there is no IC point. The answer is infinity. Huh? Okay, so this is how you do it lah. So just show you. What is important is you put in the 3 parameter. Where's your V? Where's your omega? Where is your R? Okay, label clearly. So VC follow the motion, curvature motion, tangent. VC and VB follow the curvature of your point. Omega, you know by imagining how it moves. Right, so this one, it will rotate like this. Okay, it will rotate like this lah. So it will be like this one. So it will be following this motion. It just amplifies the motion. We move down like this. So it's a clockwise direction. So omega of CB. So this one is moving like this one. Okay. Then you put in the R, RB stroke IC, RC stroke IC. This one following your body of your ruler. But important is the arrow is always from IC to pointing to the BC. But this one is infinity. This one is infinity. So our arrow pointing to the point lah. So the answer for this one is R stroke C will be approaching infinity. So this is the first time infinity symbol used in this chapter or in dynamics. Okay, usually this is a bonus mark lah. We just want you to write infinity, answer is infinity. RC stroke something to the point is infinity, and so on. Okay, and you can find the omega by using V equal to omega R. You rearrange the equation on. Okay, so in here, if you divide something with infinity to find the omega, V equal to omega R, you rearrange, you get omega CB equal to VC divided by RC stroke IC. So once your R is infinity, very big, you divide something very big, you get near to 0. But in this case, because infinity, you can straight away write 0. So omega is 0. What does it mean? What does it mean? No rotation. Near to no rotation. Near to no rotation. Okay, so this is how you prove. They always have an answer. They always have a question. Ask you to justify the motion in your test 2 or final exam. You need to explain the motion of the object by formula or by mathematics calculation. In this case, how you prove, how you justify the body of CB do not rotate. By here, by this one, by this formula. You do calculate W, you draw the arrow, and then you put in omega CB, and then you write the equation V equal to omega R. You rearrange omega equal to V divided by R. And you write this one, this is important. You write this one component, the denominator is infinity. So your omega equal 0. Yeah. So this is just a description of the body. What will the body move? Okay, so you say that the length of BC or CB, it translate, and CB will move to a tilt position, causing IC to move in some infinity location. Okay. All right. So this one is some drafting work, because if this one link longer, the point C will be going up. Then you will see the velocity will be pointing this way, and you get IC over here. Same with this one. If you extend the length of the link here, the velocity will pointing somewhere here, If it's long enough, then velocity will tilt to the down here, and you can draw the position of IC. But this one is too short. When you have link is too short, then there is no omega. Okay. So this one also same. Your homework, this one I let it to your homework, and you go and study example 8. Okay. So I skip. You go and draw. You should be able to draw the IC and calculate. I go very fast. Okay, now we go into another one. It's called relative motion to calculate your acceleration. So this one is like a garbage truck where you have a link here. There's a link that push the bin here up and down. So when you push the bin here up and down, there's a pulley here, there's a wheel here at point C. So the bin will rotate at a certain angle. So when you have a rotation, then you have rigid body motion already. Okay, just refresh what we learned before this. We have all this formula. VB equal to VA plus VB stroke A. We have, when you differentiate with time, you get acceleration. This is what you learned before this. And when you come to acceleration, you can break your acceleration. The third term, B stroke A, you can break your acceleration of your B stroke A into normal and tangent direction. Why? Because in your formula, the one on the left here, AB, is translation. AA is translation. The third term here is rotation motion. Yeah, so you have 3 dimension here. Translation equal to translation plus rotation. On the left here, it actually is a general plane. On the left term here is general plane. Okay. So what is important for this slide? Your acceleration can break into tangent and normal direction for rotation acceleration. Okay. Okay, so let's say you have a link of AB. Just need to highlight, because previously we do mention when you have a curvature motion and you have acceleration, where's the direction of acceleration? Always pointing inside the curve. Your acceleration always pointing inside the curve. Velocity always perpendicular to your curve, tangent to your curve. However, acceleration always pointing inside the curve. Okay. So if you're given a question of the results, or let's say this rod rotating in omega and alpha, omega is angular velocity, alpha is angular acceleration, rotate in the clockwise direction, so your omega is going inside the screen. Okay. Inside the screen. So, and then the body tilted at a certain way. So if you have a general plane motion, actually when you have general plane motion, then you have translation plus rotation. Yeah. So on the left hand side, your equation is always the general plane. On the right hand side, you have 2 combinations. One is translation, one is rotation. Yeah. And for the rotation, we pick one point as our fixed point to rotate. Either one, for this example, we pick point A as our reference point, so that you see the rotation motion on the far left diagram here, far right diagram here, is based on A. And what I want to highlight here is your acceleration can break into normal and tangent direction. So this is just a translation of your vector diagram. You should be able to read. So how to extract all these two diagrams, translation and rotation diagram, into one vector diagram. You should know where is your acceleration of A. Acceleration of A you extract from the translation diagram. Translation always go parallel, so it's only one direction linearly. So if you're having translation, the acceleration direction is the same. So AA was same as AB, so you can write AA in point B. So you copy the direction of AA to one side, and then AB. AB is from here. Okay, from here, from the general plane. You copy AB, put here, and then you have a resultant of your AB. So you just it will be perpendicular to each other. So you just starting, you go to the acceleration point arrowhead here. Arrowhead here, you draw to the tangent direction of your acceleration. You continue. You start with AA first, then you go to your diagram. See where is the direction of your AB stroke A tangent direction. You copy it. Then you use your ruler, continue 90 degree to connect with the AB. Okay, but this one I won't test you lah. Just for your info only lah. What is important is general plane have two combination. One is translation and rotation. And then one important formula, V equal to omega R. What is important for today lah? Okay. Okay, so here, just to recall back another formula, V equal to omega R, acceleration equal to omega square R. You've seen this one before already. Now I just recall what you learned previously. V equal to omega R, A equal to omega square R. Two formula. One is V equal to omega R, another one is A equal to omega square R. Negative, positive depends on the motion. Okay. Now, if you refer to this diagram, omega is rotating clockwise. So right hand rules pointing inside the screen, so you get negative. Yeah, you pointing inside, you get negative. Then, yeah, the rest you should be able to translate. Let's say you focus on AB and rotate clockwise. So you just focus on the motion of point B. A is fixed. So you can draw the curvature of your acceleration. Right? You can draw the curvature of your motion acceleration. So acceleration, the A tangent, you should be able to draw. And if you have fixed point A and there's a point B like this, the acceleration can only go one way for the normal. It will always follow the body line, AB line, center of the centroid of the body. So AN will always following the A there, to the center of point A. And then you can calculate the resultant of AB. How to find resultant? AB tangent square plus AB tangent square root. Then you get resultant of AB. Okay. There are two formula. AN, the normal one, the one pointing inside, we use omega term. AN equal to omega square R. Tangent one, you take alpha cross R. tangent velocity, tangent acceleration equal to alpha cross r or alpha r. There are two. Don't confuse between these two. These two, when you can calculate, then you can calculate the magnitude of the resultant acceleration. And the direction of the acceleration always pointing inside the curve. So you can estimate where is the arrow for tangent already. If it's a link, you know that there's a curve. Let's say the path is curved. You know that the curve, and you know that always pointing inside the curve. So it's in this domain. Body line, in this case, BA. So once you know the normal, you can use your ruler, and then you can draw the tangent direction for the AT tangent. This is how you break the question down, and then you memorize these two equations. If the question asks you to find acceleration normal to the center, which usually if it's a car moving, AM is the acceleration that keep the car along the track, circular track. It's an acceleration that push the car to the center. This AN. If you're playing drift, then this AN is important. If you want to do circular drift. Okay, so, and then AT always following the tangent direction of your velocity. So the complete equation is in this form. And again, this one negative, positive, the 1, 2, 3, the third term here, it can be positive, negative, depending on the motion. This one negative because your omega is clockwise. Because you're using right-hand rules. That's why here this term is negative. So this is a term. This is the okay. So on the left, again, formula on the left is general plane. The second term is translation. The third term that I highlight in yellow color is rotation motion. Rotation, you have tangent direction and normal direction. Yeah. Alpha cross r is tangent direction. Omega square r is normal direction. Yeah. So this one is one question in your tutorial, I think. So if an object is without slipping means it do not, it always stick to the floor, and all the motion is translating to the floor. Means, you know you can calculate the circumference of a circle, right? 2 pi r. So if you slip, mean the distance traveled by the round body will be shorter or longer. Usually shorter because it slip. So here is without slipping. So you have alpha, you have omega, and the center of mass G there, and A. Okay, so this one is too quick. So if you draw kinematic diagram is only seeing the velocity, no forces there. Okay, so this question is when you see the question, there's put a G in the diagram there. When you see a G diagram there, then the first step is to draw the velocity vector. In this case, because the ball is circular, the center of mass, you imagine you are the center of mass G there. What is your motion when you roll to the right? You're actually moving to the right? So your vector is x direction, with its Vg pointing to the right. This is referring to the center of mass at the center. If this round body rotate clockwise, you are moving in forward, with your arrow is pointing to the right. And then you have an interest point of A. Interest point of A always pointing to the center of mass. This one no need to think one. This interest point outside a circular body, always when you want to find the r vector, always from the outside point to the center of mass. Why? Why are we pointing inside? Because we use this analysis to calculate the circular acceleration, normal acceleration, where it's always pointing inside the curve. Yeah, so this one is just a revision. If you want to find velocity, velocity equal to v equal to vb. Last time we used b on the left, but here, if you are under effect of center of mass, on the left here is your general plane. Vg equal to translation va point A translation plus omega r. Yeah. So this is something new. It's a bit different from the previous section. This one is under effect of center of mass. When you see G in the diagram. Okay. So here, you convert into the vector form. General plane, velocity of G will be VA y0. Why VA0? Why? V point A do move, but what is the main argument point here? Why we put 0? Because A is a contact point on the circular body. If you roll a body circular, A always stationary at one contact point. So that point, if you see in the movie form, the point A do not move. It always at the bottom of the object. This point A always stay there. It do not move. Right? Okay. Means this A is actually a contact point. Contact point is not the point on the body. It's a contact point of body, blue color body and the gray color here. It's a contact point of between the two body. We call it A. So A is 0 and omega y negative. Why negative? Because we use right hand rules. This one is clockwise. So you use right hand rules pointing inside the screen, you get negative. And we put in K there because it's Z direction. Your thumb is Z direction. RG stroke A is J because it's pointing in the Y direction. Okay, pointing to the center of mass. Okay, V equal to omega R again. V equal to omega R again. So in this case, we just change the sub. Just now, your sub VA, VB, now we go into center of mass. So when focus on center of mass, we have VG. Still, we are using V equal to omega R. Once we have V, we can get the A. When we time differentiate the VG, on the left-hand side, you get A. dV, dt, you get A. Omega R, d omega dt, you get alpha. Omega is angular velocity. You time differentiate, you get angular acceleration. You get this one. Okay, still the same. A equal to alpha R. A equal to alpha R is in what direction? Rotation, you have tangent and normal, right? So alpha R is what? Tangent direction. Tangent direction. And if the question asks you normal acceleration is omega square R. This formula. Alpha, acceleration tangent direction, alpha R. If the question asks you what is the acceleration towards center, AN equal to omega square R. And positive negative depend on omega, whether it's going into the screen or outside the screen. Okay. Okay, just to prove this theory, so we go into this example. So you have a rod, have 2 points, and you're given a velocity of A. Velocity of A going downhill. You can imagine the B point motion, right? B point will go down or go up? Go up, huh? The omega, to find the omega or the R, you need velocity and omega, right? So you know the omega, right? What is the omega? Positive, negative, like this. So anti-clockwise, right? Anti-clockwise, right? So anti-clockwise is positive, your right hand rules pointing outside the screen. So you know that your omega is positive. Okay, there are two analyses. One, we use vector analysis. So the question already give you point A acceleration you are given. You have the A, you have the VA here. So V is, you know that it's rotate, right? This object rotate. So when things rotate, you actually can know the, let's say we have this point, center of mass at the center. So you know that this one rotate this direction, omega. So your A will move down here, right? Move down here. And your VB will move down there. Okay. Okay. So you can convert your rod into this diagram. I go a bit faster. So, and then you put your X and Y direction. You put in the horizontal setting like the question. You copy the question orientation, X and Y, and then you draw the body. Then you put in velocity, omega, alpha on the diagram. So V is given, A is given, so you just put in the A and V. Why we in this diagram we only interest in acceleration? Because the question asks us angular acceleration. Okay, you can put V here also same, V also this direction, A also this direction. But the question asks us acceleration. So we only put in acceleration in the diagram, not to confuse us. Then omega alpha is anti-clockwise. The value I will give you later. This one you can calculate. You can calculate. And 45 degree, and the distance is always from A. We always take the first point on the diagram. If you have A, you have P, Q, you use P, you use the alphabet that come first. Okay, if you're given C and D, you use C, and so on. Okay, the vector of R is always pointing from reference point A to B. So you write RB stroke A. So no issue for this diagram. At the moment, omega, this one we can calculate later. Okay, you know the RA, right? RB stroke A, you know, right? You know or not? RB stroke A equal 10. You have R. You have V. You can calculate omega or not? V equal to omega R. You calculate, you get 0.283 radian per second. Once you have that one, you can calculate alpha. Why? A equal to alpha R. But this one is not, there are two. You need to find A equal to alpha R, A equal to omega square R. Then you need to find resultant. This is resultant. The one in the question you see is resultant acceleration. So resultant, you have two components, tangent and direction. But this one is do not. Yeah, this one is resultant. Okay. So we can find this one. You can use instantaneous. Velocity equation means V equal to omega r. Method of instantaneous center is the one that you use IC lah. Okay. Also same lah. V equal to omega r. Also same. Okay, so this is the way you use IC. Okay. I explained on the left hand side. I already explained how to get the IC. If you go to A, you go to A point. How to draw IC? You follow the VA. Put your ruler here. Follow the body of your ruler. Draw a line. Red color dot. You have already. You know the VB direction. VB, go to use your ruler again. The base align with VB. Use your ruler to draw the yellow line, yellow dot line. You get intersection point there. Okay, this one already explained in the classes now. By now, you should be able to draw red arrow and yellow arrow already. Red dot line and also the yellow dot line. You should be able to draw by now. So, and then the arrowhead of the dot line always from the IC point. IC pointing to the interest point A. IC pointing to the interest point B. The arrowhead is important. Okay, now after the red line and the yellow line, you need to add one more parameter, which is omega. Omega, you imagine how this body rotate. This body rotate anti-clockwise. So you go to the IC point there, draw an arrow anti-clockwise, put in omega. Label your red color line as RA stroke IC. Label your yellow line as RB stroke IC. Yeah. Okay. Now, how to find R length and RA stroke IC length and RB stroke IC length? Trigonometry that I show on the right hand side here. Okay. So you have 10 meter at the bottom and you have the same side. How you know same side? Yeah, because you have 45 and 90 degree here. Yeah, this is 90 degree. We have 45, so we have 45, 45. Here is 45. I hope you can see. Your V is this way. The black arrow and the red arrow is 90 degree. So you know that you can transfer 45 degree to this corner here. You can transfer 45, a Z transfer 45 to this angle here. The balance is 45 here. Do the same for B. You can translate your 45 to this angle here. You can transfer your 45 to here. So you can transfer your 45. This is 45 to here, 45. Also same. You can transfer 45 here. So here is 45. How you know it's 45? Because it's 90 degree. Here to here is 90 degree. Here to here is 90 degree. Or here to here is 90 degree. Then it will construct a triangular like what I see on the right hand side of my slides. If you have 45, 45, you know that, and 45, 45, you know that the balance here is 90 degree. And you can split the circle into half. Once you have 45, 45 means you have same both side right angled triangular. Then you can calculate lah, according to your trigonometry formula. So you can find R length from the formula. You know it's 5. This length is cos 45. You get 7.07 length is the same and another side. So you can find V already, or can find omega. V equal to omega R. So you can either two way. One is from the diagram, one is using IC. I personally like IC method because it's much easier because I only need my ruler and then I practice the trigonometry diagram. Yeah, it's always landed at right angled triangular. Yeah. Okay, the rest is your homework. This is vector analysis. You can go home and see. You split into X and Y direction and you complete it lah. So this is your homework. Okay, your homework, example 9. This one also your homework. Go home and see. Your homework, It's your homework. It's quite lengthy, but two methods also given. One is called scalar, one is vector analysis. This one also have a look. 11 also. I think this one is in your assignment, if not certain. I'm not sure. So this one you have a look. Okay, what is important today is you know how to draw IC line using your ruler. Two formula, V equal to omega R, and also acceleration. Acceleration A equal to alpha R for tangent direction. If the question forces you to calculate normal direction acceleration, omega square R. Okay. If it's moved in the straight line, it's always tangent. So you use, if it's moved in the straight line or flat surface, your acceleration always A equal to alpha R. If the thing rotates, then in the normal direction acceleration is omega square R. Then you need to find resultant. Yeah. Okay, so we have a short break here. We continue 12:10, 12:10, 12:10. Okay.